This is Jerry with PressureWasher.net, Sirocco Vacuums, Bulldog Pro pressure washers. I want to show you the basic startup procedure on a complete everything system. This is an example that includes a inverter system for running automatic pump outs that eliminates the need for a generator. If the only thing on your trailer that needs 115 volts is a couple of automatic pump outs, then they can be done off of batteries. We've got a large charging system feeding this bank of two 100 amp hour batteries right inside this custom cabinet. We have two great big sealed lead acid batteries. There's two 2,000 watt continuous rated inverters, which is twice what this thing needs. There's three automatic pump outs on this system, and we can run two off of each inverter. So one of them is working pretty easy. So what I'm gonna do here on startup is I need to make sure that my generator runs, or my inverter runs in this case, for the automatic pump outs. So I'm gonna flip these switches on in here. And there's a light on my capacitor here that protects the charging system, and there's lights on the inverters that show that the inverters are on. They're ready to go. If your system has a generator, you want to start that generator and prove that it runs right now. Okay, so the next thing to do properly on a complete everything system is to make sure your reclaim system works. So now what I'm going to do is I'm going to go to the gas engine vacuum. I'm going to go through the typical startup procedure. I'm going to check the oil to make sure the oil is up the dipstick like it's supposed to be. Make sure there's no leaks anywhere. Everything should be fine. I'm going to turn on the fuel pump in this case, because we've got two elevated engines running from a remote fuel cell, a great big gasoline tank with electric fuel pump. So I'm going to turn that on. And then I'm going to turn the engine speed up about halfway. This engine has a choke on it, so I'm going to open the choke, or excuse me, close the choke, and I'm going to start this thing up and make sure that it runs. Okay? I'm not going to do that right now, so you can hear what I'm saying. So that's what I would do. I would start the engine up, make sure that the vacuum runs, make sure that it sucks okay, go out to the fitting on the waste tanks, which I'll show you here. If this is the automatic pump out tank that I want to connect a hose to, I'm going to make sure that you've got the really good suction right here at the point that you're going to connect a suction hose going to a vacuuming surface cleaner or puddle suckers or whatever. So you want to make sure that the engine runs. You want to make sure that the vacuum sucks like it's supposed to. If you forgot to close a valve, or if there's a fitting that's loose or something like that, like this one has a fitting that's open right here, I'd want to make sure that that was closed up when I'm ready to use the system. Just make sure your vacuum system runs. You'll put out your secondary containment, like a mat over the storm drain, put out sandbags in front of it, put out an oil absorbent sock like FaithWorks berms, for example. So in case any wash water was to head towards a storm drain, you would be capturing it. So secondary containment is smart. Just in case something failed, we would want to be able to capture the water and not get fined or damage the environment in some way. So this particular system has the primary automatic pump out tank. It also has a sand trap, so we can catch debris before it would go into the auto pump out tank. That makes your automatic pump out tank more reliable. This one has a last resort tank, so if the automatic pump out isn't pumping out all the water, then it would catch the water, and the pump out in here would protect the vacuum from any water going in the vacuum. While I'm here, I want to show you on this particular unit that we have the inverter system connected all the way up there in the front. The wires go underneath the trailer, and I have an outlet right here behind the tanks that the automatic pump outs are plugged into. It's a rainproof enclosure, so the 115 volts is protected. These are tools. These are tools that have to work. They're tools that have to be reliable. Everything you do that bulletproofs a machine goes towards the reliability and work speed, so you don't have to stop in the middle of a job. So when you have proved that your vacuum reclaim system can run, then what we want to do is go to the heater in this case. It's a 12 volt heater. Doesn't have to have the engine running to have the heater go on. So what I want to do is make sure that when I turn the heater on, it sounds like normal. It'll always sound this way unless there's something wrong. It's a good, strong blower sound that's putting air into the burner, but there's no fire yet. I do have indicator lights on this particular unit. This is telling me that the fuse is good for the control circuit. This is telling me that the temperature control is on. And there's a third light down below that'll tell me that the flow switch is on when it goes on and it's getting power to the heater. I'm going to cheat it right now and show you that I can make the flow switch think that the burner is supposed to go on, and my secondary light down there goes on. There it goes, okay? So the point is to make sure that it sounds normal and make sure that the heater only goes on when the flow switch tells it to and the temperature control's turned up, okay? So I'm gonna turn this off because it sounds like normal. It's ready to run, okay? This one has an adjustable temperature control, and it also has a secondary regulator so I can reduce the flow going through the heater for doing tile and grout. For example, if I only want to have 12 or 1500 psi, then instead of the primary regulator doing all the regulating, the unloader doing all the regulating at a full 4000 psi and 8 gallons a minute, I can open this valve here, which enables my secondary regulator. Now I'm going to get an adjustable pressure of 1000 to 2000 psi. This one's set for about 1200 psi because the customer wants to be able to do tile and grout cleaning. So when I'm done using this, then oh, and by the way, when we reduce the flow, we're adding the same amount of heat to the water flow. So if we don't want to overheat the water, we don't want to bypass too much water. So what we're going to do is go to the nozzle chart and specify the flow that you want based on the nozzles that you're using on your wand for or on your surface cleaner. You got to match the nozzles to the flow. So this particular unit is 8 gallons a minute and 4000 psi. So I'm going to go to the nozzle chart and I'm going to figure, okay, well, if I reduce down to maybe 6 gallons a minute, then I can have, let's say, 220 degrees. When you go to test it, you'll see where it wants to settle because that's what you're going to get. If you're getting a full 200 degrees at 8 gallons a minute like this one does, then it's probably going to settle at about 215, 220, something like that at or so with 6 gallons a minute. So I'm going to match the nozzle size to the full 4000 psi at 6 gallons a minute if I'm still water blasting, but I need the extra heat. Or I'll go to the nozzle size that's appropriate for 6 gallons a minute at only 1200 psi. So the regulator regulates off the extra couple gallons a minute. The nozzles are the right size for giving you the flow that you want without overheating the water. And the very first thing that you'll do when you get this thing fired up with whatever that nozzle size and whatever that pressure setting is you look at your temperature gauge and make sure that it's not overheating, okay? Now, when you're first setting up a system like this, you want to take notes on how it acts with certain nozzle sizes matched with certain pressures so that you can refer back to that list, you call it your cheat sheet, of how it performs for temperature at different flow rates. And that's the finesse of using a multifunctional heater system like this. So I've made it clear that this heater is working fine. It doesn't go on until the flow switch is actuated. So now I can go to the pump system, start the pump system. I'll go through the same startup procedure as any other gas engine. Made sure that the oil was good. This one has fuel injection, so there's no choke on it. So what I'll do is I'll start that engine and bring the engine speed up to the speed that I want to run at based on the flow. If I'm only going to run 6 gallons a minute, I only need to turn up the engine speed to where I get the pressure I was supposed to get at the flow rate with the nozzle size that I'm trying to get. I don't need to waste any fuel. I don't need to waste any horsepower. So when I've got the gun open and I've got the system connected and ready to run with the proper nozzle size I want to use, I'll use the regulator to adjust the pressure, and then I'll just turn up or down the engine speed to match the flow that we're trying to get. There's no reason to waste gasoline. So once I get the pump system running, then of course I can flip on the heater, and again you verify that you've got heat going on. The flame actually goes on only when the gun is open. You let go of the gun, the heater goes off. It must go off when you let go of the gun. If it ever stays on when it's not supposed to, it's going to overheat really quick. And all that heat is going to go right into that connect hose. The first thing that's going to blow is the connect hose between the heater and the hose reel. We don't need that to happen. Now, on this particular system, we've got really tight controls and safety devices that'll keep it from overheating like that. But I'm just saying, watch what these things do, because that's a big fire and a big heater, and overheating is a bad thing. We don't want to prove that the controls and safeties can do their job. We only want to use those controls and safeties when we have to. So that's the basic startup procedure. Again, you put out your reclaim equipment, make sure the vacuum can reclaim. You prove that your heater system is ready to go. Then you go to your pump system, and you can start the pump up. You can start the engine up on the vacuum and start sucking some stuff up. Pressure washing is something that makes you a lot of money. You got to be able to go fast, but if you're not prepared, if you don't have your adjustments right, if you're not set up to ensure that you can go fast, you might not be able to go fast.